Problem 817. A tennis ball initially moves with a velocity of 30 meters per second to the right. Let's call the tennis ball M1. V1 to the right, 30 meters per second. A tennis racket strikes the ball. Tennis racket has mass M2. It has some velocity. I've drawn it here as being to the left. After the collision, the velocity of the tennis ball reverses, so both of these are 30 meters per second. And then we're given the masses of the tennis ball, 0.05 kilograms, and the racket, 0.5 kilograms, respectively. So first off, we're asked about the speed of the racket. Does it or does it not change? The kinetic energy of the tennis ball remains the same. The speed remains the same, so its kinetic energy remains the same, which means the kinetic energy of the racket has to be the same before and after. And that means that the velocity of the speed of the racket has to be the same before and after. Okay, part B. What's the value of the total momentum of the system? Okay, so I know that the total momentum of the system is the momentum of the tennis ball plus the momentum of the racket before the collision, and that's going to be the momentum of the tennis ball plus the momentum of the racket after the collision. On the other hand, I know that P1 has to be equal to P1 prime has to be equal to minus P1. The momentum of the tennis ball reverses, and the momentum of the racket also reverses. Okay, so the reason we know that is that from here we know that there's no change in the velocity of the racket, and so the only way momentum can be conserved is for this to reverse its velocity. So let me redraw this arrow here, which I drew in the same direction, in the opposite direction. And we can see that both the velocity of the ball and the velocity of the tennis ball reverse, and so the conclusion here is that P1, P2 is equal to the minus of P1 plus P2. Okay, so if a quantity is equal to its negative, the only way that can happen is if P1 plus P2 is equal to 0 kilogram meters per second. And so the value of the total momentum of the system is 0. Okay, finally, find the initial velocity of the racket. Okay, so using the now known fact that the system momentum is 0, we can say that P1 plus P2 is equal to 0, and that V2 is the initial velocity of the tennis racket, is equal to minus M1 V1 over M2, which is minus 0.05 kilograms, mass of the tennis ball, times the initial velocity of the tennis ball, divided by half a kilogram. Alright, well there's a 10-to-1 ratio between these two, and so that's going to be a divider by 10, which is going to give us 3 meters per second, and of course the minus sign is there because with the coordinate system here assumed to be positive to the right, minus velocity of the tennis racket is to the left.